Hello, welcome back to the Flow Art Institute's Fire Safety video series. This video deals with the scientific aspects of the fuels that are commonly used in fire performance. A basic understanding of the chemical properties of the common fuels that are used to produce fire is essential to producing safe performances and creating safe fuel management practices in the context of fire performance. In the United States, although of course there are regional variations, there are 3 or 4 fuels that are commonly used in fire performance. Number 1, naphtha, commonly known as Coleman camp fuel or white gas. Number 2, paraffin, commonly known as lamp oil. Number 3, alcohol fuels such as denatured alcohol, isopropyl alcohol, or even food-grade ethanol. And number 4, kerosene, commonly known as kerosene. As you know, automotive gasoline, diesel fuel, and other unlisted fuels are not recommended due to their danger or lack of additional benefit as compared with the fuels I just listed. However, before we get to discussing each of the individual fuels, I'd like to touch on some of the important characteristics common to all of the fuels, as well as the relevant terminology. All of the fuels that we'll talk about today are classified as hydrocarbons, which means they're made entirely of hydrogen and carbon, and derived originally from crude oil. As with most products derived from crude oil, there is a health risk associated with coming into contact with these chemicals, whether they're absorbed through the skin, or inhaled, or swallowed. Unfortunately, they are all toxic to varying degrees. Each type of fuel has important characteristics, namely the flash point and the vapor pressure. The vapor pressure indicates the ease of which the fuel forms a vapor, which is important because it's actually the vapors of a fuel that are flammable, not necessarily the liquid fuel itself. As an example, a substance that we've all used, automotive gasoline, has a very high vapor pressure. Thus, it forms vapors easily. As such, you can smell the characteristic smell of gasoline from an open gasoline container that's quite a few feet away from you. Now the flash point, on the other hand, is the lowest temperature at which a solvent gives off enough vapor to burn when a flame or spark is present. Want to guess the flash point of an automotive gasoline? It's -40 degrees Fahrenheit. This means that an open container of gasoline will still give off enough gasoline vapors at -40 degrees Fahrenheit to burn. That's impressive. All of this information, and much, much more, can be found in each fuel's Materials Safety Data Sheet, abbreviated as MSDS. These documents, which I recommend that you bring to every site where liquid fuels are to be burned, are freely available online. So, let's switch over to talking about the individual fuels. Let's talk about naphtha first. In the United States, naphtha is sold as camp fuel, or white gas, and under brand names such as Coleman, Ozark Trail, and Crown. It's a National Fire Protection Agency Class 1B flammable solvent, in that it can ignite at temperatures of less than 100 degrees Fahrenheit, and that it's also able to dissolve other substances. It has a flash point of less than 0 degrees Fahrenheit, a high vapor pressure, and vapors that are heavier than air. In practice, this means that naphtha ignites easily at room temperatures, and makes ignitable vapors very easily, which can also track along the ground, and can subsequently be ignited at a distance from an open container, which contains naphtha. The high vapor pressure also means that naphtha evaporates easily, but is difficult to extinguish by fast spinning. In the realm of fire performance, naphtha is commonly used for fire performance props that spin rapidly. In practical experience, it burns longer than a similar quantity of alcohol fuel, but shorter than paraffin. Okay, let's talk about paraffin fuel next. In the United States, paraffin is sold as lamp oil or tiki torch fuel under various brands such as Lamplight Farms or Guiding Light. It's a National Fire Protection Agency Class 3 combustible liquid. In comparison to naphtha, it has a high flash point at 250 degrees Fahrenheit and a low vapor pressure. So in practice, this means that paraffin is difficult to ignite and doesn't produce vapors easily. Because of the low vapor pressure, paraffin doesn't evaporate well at all. In the realm of fire performance, paraffin is commonly used for fire performance props that don't need to be spun rapidly or need to remain burning for a longer period of time. It's also used in fire breathing where the high surface area increases its ignitability. It leaves an oily residue. In practical use, it has a long burn time, but produces more smoke and more soot than naphtha. Fire performers often blend paraffin with naphtha to provide a hybrid fuel that ignites easily but burns longer than naphtha. Let's switch over to talking about alcohol fuel. In the United States, the most common alcohol-based fuel is denatured alcohol, otherwise known as methylated spirits. It generally contains a bit of methanol as well, which is a poisonous form of alcohol if ingested. This solvent is a National Fire Protection Agency Class 1B flammable liquid. It has a flash point and vapor pressure in between naphtha and paraffin, and in practice, this means that alcohol fuels are easier to ignite than paraffin, and that alcohol gives off more ignitable vapors than paraffin, but still less than naphtha. In practical use, alcohol fuels have a short burn time, a dim blue flame, and produces the coolest temperature flame of all the common fuels used in fire performance. Furthermore, being a polar molecule, it accepts flame colorant chemicals quite easily, such as boric acid. Let's switch over and talk about kerosene. In the United States, kerosene is generally used in heating functions and as jet fuel. This liquid is a National Fire Protection Agency Class 2 combustible liquid. It has a flash point lower than paraffin and a vapor pressure as low as paraffin. So in practice, this means that it is slightly easier to ignite than paraffin, but gives off few heavy vapors which are difficult to ignite. In practical use, like paraffin, kerosene has a long burn time, burns with a smoky, sooty flame, and leaves a smelly, oily residue. Well, that's about it for our video on the scientific aspects of fuel. There's a lot of information in this video, and I'd recommend watching it again to get all of the details. Just remember that each of the fuels have different flash points, vapor pressures, and uses in the context of fire performance. Hey, thanks again for tuning into the Flow Arts Institute video series on fire and fuel safety for fire performers and fire safety personnel. For more information on fuel storage, safety, and use, please tune in to our next video. And again, I'm Howard Chen for the Flow Arts Institute.